got a really fascinating problem here that it doesn't look like much. It looks like you would just find the points where this line intersects this circle and just multiply the x and y coordinates. And that is a way you can do this. You know, the line, if this problem is going to make any sense, the line has to intersect the circle either in 2 spots or 1 spot. It could be a tangent line or it could be a secant line, they call it. But the challenge on this one is to actually find the value of x, y, this product x, y, without actually finding where this line intersects a circle. And I found this clever way. This wasn't my idea. This guy, Amit Mendelevitch, I think, solved this problem on Flammable Maths. And on Flammable Maths, they did it where they did find the points where the line intersected the circle, and they came out to be nice integer values. But I thought about, well, what if they don't come out to be nice integer values, you know? And that's this type of problem right here. Now, if you'll take a look at this approach, it's really fairly straightforward in the sense that you know that the difference of 2 squares, non-consecutive squares, is necessarily going to be an odd number. And that's what happens right here. 9, which is this number, and then 64 right here. That's the difference. This is 81 minus 64 is equal to 17. Turns out to be an odd number, not that it's that big a deal, really. All right, but the part that really makes this fly is this algebraic piece right here. You see, we are trying to find x, y, right? Not either x or either y. We're just trying to find the product in one fell swoop. And so the part that I like about this quite a bit is that Mendelevitch, I guess, noticed that you can write it this way. In other words, if you take a look here, x minus y squared, which is a step I left out right here, it is equal to x squared minus 2xy plus y squared, right? Okay, you see, and that's what led to this cool thing right here. When you subtract, this whole object is equal to this. So what he did was subtract off this piece right here, but you're still left with the minus 2xy. You see the minus 2xy here is all that's left, okay? But the whole thing is equal to 17. All right, that's given information right here. The 64 x squared plus y squared is 64, which is what happens right here. You got the 64 being subtracted from the 81, all right, to give the 17. There's your answer. I thought that was super cool. You know, you've never actually explicitly found the values of x and y. But what's interesting is it probably intersects in 2 places. And so the symmetry of it means the product is always going to be minus 17 over 2. But again, a problem similar to this came up on Flammable Maths. So thanks to that high-speed guy for giving us this problem.